Hello, everyone. How are you today? I hope everybody's doing pretty good. Thank you for being here with me today in this talk. And today we are going to be we're going to be talking about this paper. It's called the title of this paper is Fabrication of Mechanically Stable Super Hydrophobic Aluminum Surface with Excellent Self-Cleaning and Anti-Fogging Properties. Okay, let's keep going, shall we? Okay, so what is this about? So what these researchers want to do is they want to design a new coating for aluminum that is self-cleaning, it is anti-fogging, it is anti-corrosive, it's super hydrophobic. That means that is water fearing. It doesn't get wet, right? And it's durable. And let's see how they did it, okay? So, okay, introduction. So how these coatings could be achieved? Well, there's a lot of methods such as anodic oxidation, chemical deposition, chemical etching, chemical vapor deposition, colloidal self-assembly, electrospinning, solid gel. I really haven't looked up all of this, but these are methods that maybe if you like me to go through all of them, you'll leave a comment below and I'll make a video about it, okay? And has this even been achieved? And it turns out to be that a lot of people, and a lot of people, I'm talking about a lot of people, have done it, right? And the way they do it is first they have to kind of get the surface of aluminum rough, uh, if that makes sense. They have to just make it a rough surface instead of being a flat, nice surface. They have to do very harsh chemicals. They have to put harsh chemicals or do some kind of treatment on the surface of aluminum, so it is ready to uh, so they can add something else on top. Okay, the coating. So that's the way it's going to be stuck. Okay. And a lot of these people have done it. Okay, he et al, Ren et al just means yeah, this is the first author, and et al it means a lot of the other ones. Okay, so it's gonna be Ren and all the other ones. They do different types of different methods. They use different methods, like sodium hydroxide. A lot of people use sodium hydroxide just to get it rough, the surface. It probably eats the surface. I'm not really sure how they do it, but if you want, you can read their papers and get a sense of how they do it. Okay, if you're interested in this topic. Okay, so and a lot more. Okay, and let's go. So how did these guys do it in this paper? Well, some of the methods are they did some. So as you can see right here, we have the aluminum substrate. This is the aluminum. And this is a drop of water. I don't know why it's silver. I got confused, but it's water, okay? And the contact angle, it's 70. What it means is that the way they do it is, let me show you really quick. Okay. Okay. So the way they do it is they measure this angle right here. Okay. Oh, I didn't know it disappeared, but okay. So you get the idea. This right here would be 70. So if the water was all the way over here, and it would be like, let's say like right here, it would be a 90-degree, but it's not. It's 70, okay? So it's smaller, okay? It's smaller. So what that means is that if it's less than 70, sorry, if it's less than 90, it means that the surface it's wettable, or it's not hydrophobic. It just likes water. It's going to get wet. If it's more than 90, it's going to be non-wettable, and it's going to be a hydrophobic surface or water fearing, as you can see right here. What they say, that's what it's called, a contact angle. a contact angle of 70, right? 70 right here, this angle. But right here, it's a contact angle of 170. What they mean is it's a like 100 and almost 180 degrees, but it's touching this part, so it's not quite 180. And the way they do it is they put it inside the, remember the roughening, the peeling off some or scratching some surface of the aluminum. It's called etching. So they do it with hydrochloric acid and give me a second, hydrochloric acid and nitric acid, okay? And as you can see right here, they're gonna have a rough surface. It's not flat anymore. It's kind of dented. And then what they're gonna do is they're gonna put it in lauric acid. They didn't really explain why they do that, but that's the way they do it. And after that, they have a very super hydrophobic surface. Super hydrophobic. I kind of like that term, super hydrophobic. They didn't just say the hydrophobic, they say super. Okay, let's keep going. Now, let's keep going. Give me a second, I have to go back to my mouse. Okay, so let's see what were the results, okay? So, as you can see right here, this is the uncoated aluminum, and this is the edge aluminum. That's when it was rubbed, when it was dented, and this is the end product. There's not really that much difference between this and this, but it is what it is, okay? And they use scanning electron microscopy. It is a type of microscope that shoots electrons and tries to get the surface. Like I said, if you want me to show you how it works or explain you how it works, put a comment below, okay? And as you can see right here, they also did some, we're gonna start to get into all the testing that they did, okay? So they did a water jet. So this is a water jet right here. And they did a high impact. They didn't really say how much or the pressure, but this one's right here, see, sorry for that, but I have to do it. I'm a human too. And you know what? I really don't know why we say bless you. In case you said bless you, I don't know why we say it. I kind of stopped saying it, but if I don't say it when somebody sneezes, I feel I feel a little bit awkward, but hey, it is what it is, okay? So let's keep going. Okay, so they did a uncoated aluminum. As you can see, it gets wet. And now they did coated aluminum, the super hydrophobic aluminum, and it doesn't. Okay, so now they also put it in water, and the super hydrophobic sample of the aluminum floated on water for 4 weeks. And the other one that was not coated with anything just sank. They also did some tests with insulation tape. They did a bunch of peeling, about 100 times. They said they did the peeling, and it still kept being very hydrophobic. Okay. Now let's keep going. They also bent it, as you can see right here. They bent it, and then nothing happens. It's still hydrophobic, and they did not bend it, so they unbent it, if that's the word, or they released it. They released back to the original position, and then they did it again. And as you can see right here, it should have been peeled off all the coating on this side where it was bent, but it didn't. Okay, so that means that it's very resistant or very elastic, the coating, whatever you want to call it, but it is durable. What they also put some chalk, powder chalk on it, and this is uncoated aluminum. This is a super hydrophobic. So that's what they mean by self-cleaning. Self-cleaning is that when water hits the surface, it's going to drag all the chalk or the powder or the dirt, soil, dust, whatever, okay? But it's going to be self-cleaning. So if you just put some water in it, it's going to get clean. And this one does not. Also, what they did is they tested it with some low temperature and super hydrophobic on too low temperature on uncoated. And okay, so what they did is they just had very, I would say, very they just had condensed droplets. So they didn't really explain how they did it, but I want to say that they put maybe some vapor on it. And I'm not quite sure if it's supposed to be. They said it was low temperature, but it could have been high temperature. But the point is that they did a condensing test, and this one got wet and the other one didn't. Okay. And now the final part and the last part, your favorite part and my favorite part. What is this? How can we translate this research to the real world? Okay. So what we can do is the industry or yeah, usually the industries can just use these coatings. I'm not sure if it's dangerous or they didn't really talk about health effects or they just talk about applications in industry. So, but imagine if you don't have to wash again dishes ever again because you can just rinse it with water and here it goes. All the dirt, all the uh, oil and everything just washes away. Okay. Now that would be pretty cool. And I also like this motorcycle right here. It's called Damon. It says that it runs up to 200 miles per hour. That's insane. The fastest I've gone in one is about 170, 160. After that, I got scared, so I slowed down. I would say my bike was pretty fast, about 180. I've never wanted to test that. But okay, so that's all I have for you guys today. And in the motorcycle, we might have some rims, this part right here, because I always struggle with this part, cleaning it and the inside part, the rim, because it would always get dirty with oil or dust. So, but if you can have it bright all the time, that would be pretty cool. Also, maybe, yeah, that's about it. And probably the discs or this part right here, if this frame is right here is plastic, but if it's a metal aluminum, that would be pretty cool. And I like the carbon steel right here. I don't know who's the manufacturer of who makes this motorcycle, but I hope Kawasaki or a Japanese manufacturer, because the Japanese bikes are really good. Okay, that's all I have for you today. I love you guys and I will see you tomorrow, okay, in the next video. Bye bye now.